Hi guys, looks like you have discovered the surface area of Right Cylinders Notes video. So make sure that you have your notes ready and that you're filling them out as we go through this video. This, of course, is just going to be kind of continued from what we started with the prisms. Cylinders are prisms, they're just with a circular base rather than with another polygon base. And our objective is the same objective. So you're going to be writing down objective 7G B6 again, which is just solving real-world and mathematical problems involving area, volume, and surface area of 2- and 3-dimensional objects composed of triangles, quadrilaterals, polygons, cubes, right prisms. So make sure you've got that objective copied down, and let's go ahead and get started. As I said, today we're going to be finding the surface area for cylinders, and again, cylinders are just a special type of right prism. It's just that their base is a circle rather than, some straight-edged solid. But the first thing that we're going to do, I know with the prisms we had done the nets. Well, we're going to kind of do it backwards today. For cylinders, we're going to start with lateral area. And the reason being is if you've ever cut a label from a soup can is a real-world example of a cylinder. So you notice, though, when you take the label off that it actually creates that rectangle. So I think because a soup can is a little bit more understandable in real life, we will start with the lateral area. So the height of the rectangle is going to be the height of the can. Or your cylinder. So if this is your height right here, that means that if you don't have the picture of the lateral area, you can imagine that it's going to be the height of your rectangle. And then the base length of the rectangle, which is this one down here at the bottom, is actually going to be the entire length or distance around the can's base, which we call the circumference. So the bottom of that rectangle is going to be the circumference, and the height of the rectangle is just going to be the height or the altitude of the can. So let's see if we can put that into play. What we're going to do is we're going to write our formulas first, and then we will do our examples. So the lateral area of a cylinder is the product, meaning that we multiply the circumference of the base and the height of the cylinder. The way that we write this formula, lateral area equals, we've got our 2 pi r. And if you recall from the wonderful song that I've been singing in class for about a month now, that you can see me spinning on a car, circumference is 2 pi r. So this right here, the 2 pi r of the lateral area formula represents the circumference of that base. And then we're going to multiply it times the height, just like we said in the former example, and that's going to give us our lateral area. In order to find the surface area, though, we also have to add to that the sum of the two bases, the area of the two bases plus the lateral area. So the total surface area is, the formula looks like this, where we have surface area equals our lateral area, which actually is pretty involved just finding that, but then we have to, on top of that, go ahead and find the area of the base and then multiply it by 2 because we have two bases. So let's get started. The first example that I'm going to do, we're going to walk through this one together, and then the second one I'm going to kind of have you guys see if you can figure it out on your own. The example that I have here, though, is a can of Campbell's Chunky Soup. So like I said, soup cans, any kind of can really, is a very, very, easy example for a cylinder. Of course, there's many more, but this one is just the one that always pops to mind for me. We're going to find the surface area of this can by using the formulas that I just showed you. Of course, step 1 is going to be to find the lateral area, and we have that formula for cylinders to be our circumference times our height. So the circumference, again, just like with a prism, the circumference of the base, and then times the height of the actual prism, so from base to base. So I've highlighted it here. Let's go ahead and start that calculation. It is going to get a little bit crazy, but our radius, as you can see on this example, is 3.5 centimeters. So I'm just going to bring everything down. I'm going to bring my 2 down. I'm going to leave pi for a while because pi is probably what I want to do last, and I don't even know that I'll change it right away. But I'm going to insert my radius, which is 3.5. So right here we've got 2 times pi times 3.5. That is going to give you your circumference. But then because we are doing lateral area and not just the circumference of a circle, we need to multiply that times our height, which is right here, our 11.5. So a little bit of simplifying, and you'll multiply 3.5 times 2, which is 7, and then 7 times 11.5, and you end up getting 80.5 and pi. And I'm just going to leave the pi there. I'm not going to actually multiply by 3.14 right now because we can keep it a little bit simpler by just leaving it at 80.5 or 80.5 pi. So let me bring that onto this page. This one we got to be 80.5 pi. And now we're going to go ahead and we're going to try to find our surface area. So here is our formula for surface area. We've got surface area equals our lateral area, which we already have right here. So let's go ahead and write that. So our lateral area is 80.5 pi. And that is plus 2 times the base. And remember, I kind of started explaining this yesterday, this B, this capital B. It represents the area of the base, but depending on your base, it could be completely different, from another prism. So for this example, a cylinder has a circular base, so we're going to have to find the area of the circle. So in order to find area, again, go back to that song that we've been, singing for a month now, but circumference is 2 pi r. I roll with it, boy, I'm not scared. My area is pi r squared. So we can just take that equation that we've memorized and we can start substituting and figuring out what our final answer is. So 2 times pi, and then my radius, which is 3.5 centimeters, so 3.5 squared. And don't forget that for order of operations, you need to square before you multiply by 2. So 3.5 times 3.5, I believe, was 12.25. And then times 2 is going to be 24.5 pi. So let's combine 80.5 pi plus 24.5 pi. So 80.5 plus 24.5 is going to give us 105. And that's not just 105, it's 105 pi. If you've noticed, keeping things in terms of pi has made it a little bit simpler. At this point, I've solved for the final answer. The exact answer is 105 pi. However, I would probably want you to put it into, terms of a number rather than just a pi expression. So I would have you do 105 times 3.14 or times the pi key. So once we multiply that out, we find out that our actual surface area can be estimated to approximately 330, and then we want to make sure we do our units square centimeters. So as I said, this is quite a process because just finding the lateral area is pretty involved, and then finding the area of the base of a circle is not the easiest. But I do want to have you try an example on your own. So the example that I'm going to have you guys try on your own is example 6, and it actually doesn't have a picture. But what it says is find the surface area of a can with a radius of 5 centimeters and a height of 20. So kind of going back to what you know about the question we just did, you could still draw a sketch of a can where you've got your base at the top with a radius of 5, and then you could just improvise and draw that can and give it a height of 20 centimeters. So depending on if you need a visual or not, you can do that. You do not need that picture necessarily, though. What I would like for you to do now is to go ahead and pause the video and attempt to solve this on your own. And I will go ahead and give a few hints. I won't put the answer on here, but I want to see how far you can get on your own before you need the assistance of the video. So if you're still watching and you are wanting to see a little bit of how to get started because you're just stuck, you're going to start with step 1, which is finding the lateral area. So we're going to take the formula that we've learned today, which is lateral area for a cylinder is 2 pi r h, 2 pi radius height. And just looking at our information over here without our picture, our radius is 5, so we just substitute 2 times pi times 5, and then times our height, which is also over here, which was 20. And then you're going to simply, you're just going to simplify, so 5 times 2 is 10, 10 times 20 is 200. So for our lateral area, it looks like we've got 200 and pi. And I really would leave that as 200 pi for right now. And you could go down and even put it in down here, 200 pi. And then the hard step is doing the plus 2 times the base, because we have to figure out, you know, if it's a can, what shape is the base. And obviously it's simple because we're doing just cylinders. But if you were doing a mixed set, you would have, you know, squares, triangles, trapezoids, whatever to choose from, and you'd have to know that you have a circle that you need to find the area of, because it doesn't tell you. All it tells you is just this capital B. But we know from our experience that the area of a circle is pi r squared. And because we have 2 bases on a cylinder, not just one, we're going to multiply that times 2. So at this point, I'm going to let you take over. And if you need to look back, you know, your radius is 5. But you're going to plug 5 into that spot for your formula and simplify, get it in terms of pi. Then I want you to combine that answer that you got in terms of pi with 200 pi, and then you can take it from there and put that number into the calculator times 3.14 or times the pi button, and then you're gonna well, no, you're not ready to bring it up to me yet, actually, because we're wrapping up this lesson. I want you to also answer the essential question before you come up. I would like for you to write a paragraph or at least 3 or 4 sentences explaining how to find the surface area of both a prism and a cylinder. Remembering that a cylinder is a prism, it's just a prism with a circular base. So kind of give me a step-by-step process. There are many ways that you can find the surface area. Using lateral area and the bases is just one way. Some people like to use the net, so whichever way you prefer is going to be the way that you describe, but I do want to have 3 or 4 sentences so that you can prove that you understand it. And then bring it up to me and we will get you moved on to the next step.